Rev up your engines! There's a computerization of modern cars. Even when they're sitting, they're draining a little bit of electricity. You have to actually measure it with a meter. But the problem with that is, in order to measure it with a meter and wires, you gotta still disconnect the battery. And on many modern cars, when you disconnect the battery, it creates all kinds of problems. Numero uno, if you have one of those radios, that when you disconnect it, it says anti-theft, put in the code, then you gotta put the code, you might not know the code, but it's a lot worse than that. Some cars, you disconnect the battery, the alarm systems start acting up, and many of them, like Toyotas, you disconnect the battery and put it on, then they'll idle poorly for a while because the computer got confused and it's got to reset things. Really fancy modern cars, especially the European ones, you disconnect the battery, you actually have to get a fancy scan tool and a mechanic who knows how to operate it to reset the stuff using the computer, because they're so complicated that they need to reset how the idle is. Electric power windows wouldn't work right. Then I got to hook my fancy computer up to them and then reset those systems. So it can be a real mess on a modern car if you disconnect the battery cable. But here comes the magic. With one of these meters, you don't have to disconnect the battery cable. This just clamps over it to measure the drain that's occurring. Now, yes, this isn't a new invention. These current clamps have been out for a long time. Here's the one that I've been using, this particular setup with this and this. Hey, you're talking over $1,000 when I got them originally. They do the same thing, but they were two pieces. This wasn't standalone. This would measure it, and then the meter would give you the reading. Very expensive. Now, if you're a professional electrician and you're up in the poles and you're messing with thousands of volts, yeah, you still want to buy one of these expensive ones. The true magic is this particular one. It's an Astro AL one made in China. It measures the current. This thing was like $24 on Amazon. And yes, it actually works. I tried out a few of them. This one worked as good as any of them. $23. Hey, you're only dealing with small power in a car. It's a 12-volt system. It doesn't use that many amps. An inexpensive meter like this one can work perfectly fine when you're working on a car. I mean, yeah, I wouldn't take it up on a telephone pole. As a matter of fact, I've even used this in my house on 120-volt lines for measuring stuff, so it works great for that. But for cars, it'll probably last forever because it's such low voltage. You don't need the really expensive stuff when you're dealing with low voltage and low current. These work perfectly fine, and it really amazes me that the Chinese can make this thing as one unit. It's got voltmeters on it too. It does all kinds of other things for $23, and they work good. If your battery keeps going dead, first thing you do is to check for drain. You just click this on the low amp setting because these are lower amperage. Then you don't have to disconnect anything to see if the battery is drained. You just open the clamp up, put it around the negative battery terminal, then read the reading. And here we go, the reading is exactly that, 0. And to make sure that it's working, now the parking lights are on, and let's look. Does it show a drain? Yes, it does, 0.49 amps. The acceptable drain, 0.035 amps. So that's what's allowed. This shows that it's a lot more than that. Well, I turned on the parking lights. It only makes sense, right? But let's check a more modern car. It reads 0.029. Now, 0.029 is within the specifications. The maximum of a normal car is usually about 0.035, and that's 0.029, so it's within specs. But of course, with electronics, things are never that simple. Some modern cars have a lot more basic drain. On some modern cars, it's allowable to have 0.075, and unfortunately, you can't just look this stuff up in a book. Nobody's done that yet. Maybe they never will. So what you do is, if you got one of these, hey, like I say, they're $23. If your car's working fine, do a test on it. Write down what your normal drainage. It starts and stops all the time. You don't have to jump start it. See when it's been sitting overnight what the normal drainage is, then you know what's normal for your car. Maybe yours is 0.075 and it works fine. That's okay. But you notice I said sitting overnight. Modern cars with all these computers, sometimes it takes a while for them to go to sleep, sometimes hours. So if you drive your car, pull in the driveway, shut it off and do a test, you might find a relatively big drain. It's the stupid computer which hasn't gone to sleep yet. So you want to test them first thing in the morning when they sat all night and you haven't been driving around. because I've tested these things over the years, and some of the BMWs and Mercedes, hey, if they drive it in here, even if I check it an hour or two later, it'll still show too big of a drain unless it's been sitting overnight. So it's a good idea, you know, buy one of these $25 gauges, check it when it works fine, then you know, hey, if you got a problem, first thing you do is check it, and if it's a lot higher than what your normal drain was, you know you got a problem. And as I said, checking it with one of these non-contact jobs, you're not disconnecting the battery, so you're not letting the electrical system go haywire. You're just checking it without damaging anything. So let's say you found you have a big drain on your battery. Well, it's easy to trace down the circuit that it's in with these. When you clamp it on, you just have to go to the fuse boxes on the car. Then what you do is, once you get them out of the way, you just start pulling the fuses out one at a time. Then watch the reading on your meter. If it starts dropping down, either goes to 0 or say goes from 0.1 to 0.4, you know that circuit is the circuit that has the drain in it. Now, of course, nothing is totally magic. You pull the fuse, the drain's gone, great. Then you know that circuit has a short. Unless you're lucky and it's something you don't care about, like let's say it's the dome light of the car, and that's the only thing that operates. Well, you can either trace through the whole system and find where the short is, which is usually inside the dome lamp itself where the switch is. You can just live without it and not plug that fuse back in. But if that short is in the running system of the car, fuel injection, ignition, or something that you want to have, like the radio, then you got to trace through the wiring and find where the short is. Just realize that shorts, unless your car's been wrecked and the wiring's been crushed, normally occur at either end of the system. Let's say it's the radio. They generally occur inside the radio itself, in the wiring at the other end, where it connects to power. Older cars, a lot of times the fuse boxes, they'll corrode, and you can look under there, see there's a bunch of corrosion where it's shorting out. Electrical shorts occur at one or other end of the circuit in a car. Unless, like I said, they're in a wreck and the wires get pinched, and then all bets are off. You're just gonna have to trace all the wiring to see if some of it got pinched in a wreck and it's now touching the body. But at least you know what system the drain is occurring in. You got bad luck and you pull every single fuse of the car out and the drain hasn't changed, it still shows on the meter. Well, realize there's a lot of things in your car that don't have fuses on them, like the starter. So then what you would do would be you'd go to the starter and you would disconnect all the electric wires that plug into the starter. Then if the drain left, you would know the starter is shorting it out. Same thing goes for the computer. Let's say it's the computer that's shorting it out. Then what you do is you'd go where the computer is, and they got a zillion wires going in. All you would have to do is start unplugging those wiring harnesses that plug into the computer. And if you unplug one, then the drain drops, you'll know you have an internal short on the computer. It's a very safe system. You don't have to take anything apart by the battery, so you don't lose any memory, and you can still find out where the short is by looking at the gauge. See, the gauge is 1.2, and it can only be 0.035. Disconnect something and it goes back down under the 325, you know that's your problem and you need to fix that. So realize, yeah, we can't see electricity with our eyes, so you need gauges to work on vehicles when you have electrical problems. But the best type is a non-contact one like this, where you do not have to disconnect the battery and create electrical problems in a modern car, or get electrical probes that will probe into wires and then it contaminates the wiring. Corrosion can get inside. You could even do something bad, like I've seen guys that didn't know enough about electricity except enough to do damage, and they would probe wrong wires with wrong power supplies, and they would put a 12-volt tester on a 5-volt computer line and fry it. This thing can't hurt anything. The only thing you're doing is measuring the current going through the wire, and you're doing it indirectly through the magnetic field that goes through here. You don't have to worry about doing any damage with a tool like this. And as I said, the amazing thing is that this thing's $23 last time I checked, where my fluke meter, hey, you know, when you buy the fluke meter, then you got to buy the meter that goes to it, that plugs into it, because it's not one unit. You're going to spend maybe $1,000. It just amazes the heck out of me that you get something for 23 bucks. This car keeps going dead. Is it the battery or is it the car? We're going to find out which it is, and we're going to show you a story of how bad Optima batteries have gotten. He found out that Optima tried to sell him a battery that was 999 days old. Now, let me tell you something about batteries. Batteries are like eggs. You want them fresh. As soon as the acid is put in the battery, it starts to degrade. When I was a young mechanic, we sold vacuum sealed batteries. There was nothing in them. They were vacuum sealed. We'd punch the vacuums, we'd pour acid in, and we'd charge them on the machine for an hour. But nobody's got patience anymore. So they fill the stinking things at the factory. As soon as they're added, they start to degrade. In this case, that Optima battery was 999 days old and had hardly any of the power left in it. Right? A little bit less than 4 years ago, he replaced the battery with this battery. It's an Odyssey battery. It's absorbed glass mat, which are very good batteries. It's January 2024. August 2023, he had to start jump-starting this thing if it said so. We're going to try to figure out, is the battery just gone because it is 4 years old? Or, on the other hand, is there a short somewhere in the car that's draining it? So we got our battery tester out here. Start with the battery health test. It's an AGM flat plate. That's the new battery that he bought. Okay, it's looking for floating electricity. Said it's 850. Again, I hate the slide because the slide, look how hard it is to get it to 850. It's a bad design. They should make this better. It's almost impossible to get it to 850. Look at it, look at it, 830. It's driving me insane. Okay, we'll do 857. That's close enough. The battery has 100% capacity. It has 55% of its battery life left. Okay, so although there's 55% left, it is almost 4 years old. So you're going to lose stuff. But the capacity is 100%. So we're going to do a starting system test. There's the key. Oh, we got to push our foot on the brake. All right, everything's normal. Okay, so indeed we know the battery's good, the starter's good, it's not draining too much. So let's do the charging system. System health test. You already started it. It's checking the diode ripple. Normal so far. You can see that's the voltage, and it's got 0 ripple, so that's good. So we'll rev it up to 2,500 RPM, and here we have it. It's charging normal with the loaded voltage, but with the no load voltage, it's charging too high. Either there is a short in the system that's making it overcharge when it's idling and not when it's revving real high, or we got a bad alternator. All right, breaking news though. I just found out that the battery terminal here is loose. I asked him what this wire was. He said it's for these lights he put in the front, and it was all loose inside. So what we're gonna do is loosen this up. It's already loose anyway. Put it on the inside. I'm gonna put it here. Instead of out here, it's going to go on the other side, where it's not going to be affected by the turning of the bolt. And we're going to get it super tight. You can see how many turns it's going. We know it was definitely really loose. You always want these super tight, so it's also a good idea every once in a while, check them. Hey, that one's a little loose too. Now they're super tight. So we're back to testing the charging system now with everything tight. Go to a battery tester. And we want to do a charging system health again. Start the engine, it's already started. Here we go. Then we're going to rev it up in a second. Okay. Here we go. We're going to rev it up for 5 seconds. All right. Guess what? It's still overcharging. Now, I've learned throughout the years, don't always trust machines. So, a $5,000 hotel with a charging system on it. Okay? So, we're going to do the in-vehicle test. Do a standalone diagnosis. Here we go. We'll start the test. It says the battery is good. It says it's 87%, 901 crank, 850, so the crank is good, okay? Now we're gonna do the rest. Ensure the ignition is off. Starting's all normal. Doesn't like this cold weather, let me tell you. Okay, now we're gonna put it at 3,000 RPM. There we go. Okay, now turn on the headlights and the AC. Now rev it up. Now the no load voltage is coming down. It's not in the red yet. You can see it's the same as the high load. And this is why more expensive tools often work better. Okay, you saw the other tool, the cheaper one, it said it was too high. This says it's still in specs, where the other one said it's too high. This thing is extremely accurate, and it's telling the truth. Now, I did notice one thing. The starting voltage when the battery terminal was loose and we didn't know it, we checked with the other machine, was really high. This time, the starting voltage was a lot lower, because if you have a loose battery terminal, especially the ground, it's going to draw a lot more power because it has to send power through the loose connection, which is an added point of resistance, so it's going to use more voltage to start the vehicle. But it all makes sense now, and it actually shows how good this Odyssey battery is, because he's been driving it 4 years this way. So I went like almost 3 years with no problems. Then the last 3/4 of a year, he's having occasional starting problems, right? Where he has to jump start it. But it can all be just because that terminal was loose. So what did we learn today? Well, a couple of things. One, you gotta have good testing equipment when you're working on electrical systems. Even I, the great Scotty, cannot see electricity, right? I gotta trust these machines. And if you get a machine that's not trustworthy, you're going down the wrong rabbit hole and you're screwed. Two, we learned that something as dumb as a loose ground connection, so the terminals wiggle or any of the wires hang on super tight, can cause the weirdest problems. I mean, think about it. That battery was put in almost 4 years ago, and the terminal was loose, but it took over 3 years for it to affect the starting of the car. Now, maybe he had it on snug but not tight. It is a Subaru. Those boxer engines do have a certain amount of vibration, and it might have just vibrated loose. That's why it's a good idea every once in a while, get yourself a wrench, go to your battery terminals, and just tighten them up, you know? Because, hey, things wiggle over time. That's one of the big problems with fully electric cars. You can have all kinds of problems. At least this is just a regular car with a regular battery, and hey, you saw it was really simple to do. He's still got a reasonable percentage of lifespan left in this vehicle, because, as you saw from my second scan tool, it said it had 87% left. Okay? The other one said it was like 50% left of the life, because it is 4 years old. So, one, it shows you gotta use good equipment. And two, before you do anything, and I gotta admit, I screwed up on this one, I should have made sure that these terminals were super tight and weren't loose, because this one was loose. But not being one of those greedy modern mechanics that charge between $150 an hour or $200, hey, I don't charge anything. I make videos out of this stuff to help everybody out. So it costs nobody anything, and it could save you a small fortune. The next time you got an electrical problem, first make sure the terminals are tight, because it can create all kinds of wacky problems in a modern vehicle just because they're loose. But I still stand my bad analysis of the scan tool, saying it's not that good, because after I fixed the ground, it said it was still charging too much at idle. But the good one said no, it's charging the same at idle as it is at a higher speed. Now, it was 14 point something volts, which is relatively high, but if the battery terminal is loose when you're charging the battery, guess what? It doesn't get all that electricity because it's loose. So this battery is going to be charging itself up quite well for the next week or two as it's used, because the battery is somewhat low because the terminal was loose. Now, it doesn't seem to have ruined anything, but I've even seen it where a loose battery terminal, it'll fry an alternator, and the absolute worst thing that I've ever seen them do, and you never want to happen to you, is if it's loose and you get voltage surges, it can fry your thousands and thousands of dollar computer in the car. So, now you've learned a little bit about electricity, how you need good equipment to check them, and you always got to do logical things first. Before you check the battery and everything, make sure the stupid terminals are super tight. So if you never want to miss another one of my new car repair videos, remember to ring that bell.